Hey guys, today we are starting chapter 7, which is all about polynomial functions and factoring. So for this first section, for 7.1, we are just focusing in on how we add and subtract those polynomials, as well as start off with a little definition on what a polynomial is. So a monomial, we'll start a little bit further back. A monomial is a number, a variable, or a product of a number and a variable with whole number exponents. So what that means, now we're going to look a lot at root words today to help us identify what different words are, help us remember. In the grand scheme of things, what we should remember here is that end sound, M-I-A-L, meal, means number of terms. So a monomial, mono is one, so it is a one-termed expression. So we could have it be 3, which is just a number. We could have x, which is just a variable. 3x, 4x squared. All of those are just examples of monomials, separate from each other. Each of those are all examples of what a monomial is. The degree is the exponent of the variable. It's the exponent of the variable. So for the example of that monomial 4x squared, the degree would be 2. Or if we had something like x to the 5th, that has a degree of 5. A polynomial, poly means many. So poly means it's a monomial or the sum of monomials. So it could be one term, it could be two terms. It's any number of terms that is just added or subtracted together. So we have some different subcategories as well. Polynomial is just the generic term. It encompasses everything, all of our different expressions. We already talked about a monomial being 1. A binomial means there are 2 terms. A trinomial means there are 3 terms. Just like a bicycle has 2 wheels and a tricycle has 3 wheels. So a binomial could be something like 2x plus 3. A trinomial could be 3 plus x plus 4x squared. So could be any number of terms. Now getting into how we categorize this, because the first one, the example that I gave for the binomial, that looks good to me. The one I gave for the trinomial looks a little off to myself. In math, and when we're talking about polynomials, we have something called standard form. So it's a format that we always write our polynomials in. And standard form of a polynomial is just in descending exponent order, which means exponents get smaller to the right. So as I move from left to right, my exponents start big, and then they get smaller as you move to the right. So if I was going to rearrange 3 plus x plus 4x squared, that in descending exponent order, my biggest exponent term is 4x squared. And then my next biggest exponent is x, because that has an x to the first power. Even though we don't see that exponent, it has a 1 on it. And then my 3, that is what we call my constant, which I'm getting a little ahead of myself. My constant doesn't have a variable term on it, so it's our smallest exponent term. The degree of the polynomial. So now this is a little bit different. Our degree of any individual term is just its exponent, but the degree of the polynomial is the highest, I can spell, is the highest degree of any of its terms. So in, again, this example of 4x squared plus x plus 3, that has, the polynomial has a degree of 2. Now, this, I'm going to put a little asterisk here. This is only when there is one variable. So if I'm dealing, like I have here, even though I have multiple variable terms, it's all just x. Right? There's no other variables, there's no y's, there's no z's, a's, b's, n's, q's, any of those letters of the alphabet that we could use. Since it's just one variable, it's just whatever the highest degree is. If there are multiple variables, multiple variables, such as 4x to the x to the 7th plus 8y to the 4th plus x squared plus y plus 3. Your degree is your highest exponent on any of your individual variables added together. So in this case, the highest degree on x is 7. The highest degree on y is 4. So the total degree of this polynomial would actually be 11. Now, I only throw that at you because there's a couple of homework questions that have multiple variables. Most of what we're going to be dealing with, in fact, almost all of what we're going to have to deal with moving forward, is going to be single variable stuff. So it's just the highest degree of whatever your exponent is. All right, last two things here for our definitions, and we'll get into some actual problems. The coefficient, we've used that term coefficient before. A coefficient is just the number in a term that is in front of the variable. So again, for the example we've been using, I'm just going to keep using is 4x squared plus x plus 3. I have coefficients of 4. 4 is a coefficient. And in this case, actually, even though I don't see anything, positive 1 is also a coefficient. This last thing over here, I know I previewed this before. I didn't have this written up as a separate term, but this thing, this number that doesn't have a variable attached to it, we call that the constant. And any polynomial is going to have at most one constant, because you can never have more than one terms that don't have a variable attached to it, because otherwise they'd get added together when we start collecting our like terms, which we'll get into in just a second. Last but not least, our leading coefficient is just the coefficient of the first term. So once we have it in standard form, so for example here, for the one we've been continuously using, we're just beating this dead horse, our leading coefficient, I'll just abbreviate that down to LC, our leading coefficient is positive 4, because once it's in standard form, that's my term out in front. All right, so those are all the definitions. Those are all of our definitions. If you need to, now that they're all done, go ahead and pause. Make sure you guys got all those copied down before we move on to some examples of how we classify polynomials. All right, so classifying polynomials. This is pretty standard in terms of what we'll see in terms of example problems. We are asked first to write this polynomial that I'm given in standard form, and then we're asked to identify the degree and the leading coefficient of that polynomial. So we have to make sure we do that first. I know it's written in that order anyway, but in order to know at least the leading coefficient has to be once it's in standard form. We have to make sure that that is in the correct order. So just looking through this one to put it in standard form again means highest degree term first. So my 9x squared is the highest degree term. It has a positive in front of it, so it's going to stay as a positive 9x squared. My next highest term is this x term. It was a negative 2x, so I'm going to keep that as a negative 2x. And then, of course, my last term, the only thing that's left, is my negative 8. You got to make sure that those signs stay attached to the numbers that they originally belonged to. So when I'm rearranging this, I wouldn't have, put my 9 out in front with the negative sign that was with 8. The signs stay with the numbers. So that would be my answer in standard form. And now that I have that, I can do my degree, which I'm actually going to abbreviate down, my degree and my leading coefficient. Now my degree of this polynomial, we're dealing with just a single variable. It's just x. So my degree is just the highest exponent I see, positive 2. And then my leading coefficient, now that I have that in standard form, the number all the way out in front is 9. That's it. All right, for example 2 here under classifying polynomials, we've got slightly different instructions. We're still asked to write the polynomial in standard form, but then we're identifying the degree and then classifying it, the polynomial by how many terms there are. I remember for a polynomial, we have 3 special names based on how many terms there are. Monomial, 1 term. Binomial, 2 terms. And then trinomial, 3 terms. So for part A here, negative 3z to the fourth, that's only one term. There's no other way of rewriting this, so it's already in standard form. I don't need to rewrite this at all. So all I have to do is identify the degree, and we're asked to classify, which sometimes this is called the type of polynomial. I'll just usually call it classify here. So my degree, that's just matching my leading my highest degree, my highest exponent, which is positive 4. This only has one term to it, so this would be classified as a monomial, if I can spell, monomial. Okay. Part B, we got to put this in standard form first. So highest degree first, 5x squared, and then my next lowest would be negative x, and then my constant all the way at the end, positive 4, degree, and classify. So my degree here would be a positive 2, since that's the highest exponent in this polynomial. And then classification-wise, there are 1, 2, 3 terms, 3 being trinomial. Trinomial. Triceratops, 3 horns, tricycle, 3 wheels, trinomial, 3 terms. All right, last one here, part C. So now we've got 8q plus q to the 5th. Now remember, putting in standard form means the highest degree goes first, not the highest coefficient goes first. So here, even though 8 is the bigger of the two for my coefficients, this q to the 5th power is my highest degree. So it goes first when we put it in standard form, and then that 8q goes last, or second, whatever. Degree would be positive 5. That's the highest degree we have. They're both the same variable, so I just go with the highest degree. And then to classify this, there are 2 terms, which would be binomial. Bicycle, 2 wheels. Binomial, 2 terms. Okay. Now getting into some operations with polynomials. So our 2 operations that we're focusing in on today are addition and subtraction. We've already done this before. It might just have, it'll come back to you here. Adding and subtracting polynomials is basically just a more, not necessarily more complicated, but just a different way of framing collecting like terms. Because that's really all we're doing. When we're adding 2 polynomials together, we're just combining those 2 terms to find what the end coefficients are going to be. When we're dealing with these, when we're adding polynomials together and when we're subtracting polynomials, our degree and our variables do not change. The only thing that is changing are the coefficients, the numbers out in front. Because if we have an x squared and an x squared that get added together, it's just a different number of x squareds. It's not going to become an x to the 4th power or x times x squared being something else. The variables and the exponents stay the same. All you're doing is changing those coefficients out in front. So when we're adding 2 polynomials together, so looking at number 3 here, even though we have parentheses around the outside of these, we know that if we're adding and there's no number on the outside, right, technically it's just a 1, these terms just stay the same. So I'll show this for this first one, but then you could just know that my terms don't change. So if I distribute that 1 into this first parenthesis, my terms stay the same. If I distribute this 1 in my second parenthesis, x plus x squared plus 6, they stay the same, right? So eventually we can get to the spot where we just ignore the parentheses for addition problem. So what we have to do is collect up our like terms. So any x squareds get collected together and they become their own x squared term. Our x's get added together and they become their own term. And then our constants get added together and those become our own term. So there's a couple of different ways of organizing this. Some of you might be able to just look at these problems and just find your solution if you guys are kind of mentally organized enough. Others of us might want a strategy on how to keep them organized. So what I usually suggest, you can either use different shapes to box around the outside of it. You can use different styles of underlining for like terms. So like what I usually do, I will go through, right, there are my 2 x squared terms. I'm going to get those together. Here is my x terms. I'm going to collect those together, and then maybe like a curved one. Those are my 2 constants. I know that anything that is underlined gets added together. Anything that's squiggled gets added together. Anything that's curved gets added together. Those are my like terms. Because now it's just a fact of, or the process of actually adding them. So 2x squared plus 1x squared is a total of 3x squareds. X plus x is 2x. And then negative 5 plus 6 is positive 1. So if I added those two polynomials together, I would get 3x squared plus 2x plus 1. Number 4 is quite a bit more complicated. Now we have 3 different terms that have to get added together, 3 different sets of parentheses. So this is one where, because I have so many different terms, I'm going to go ahead and I like to also box things in, circle, draw triangles, whatever. So I'm just going to go through these to find stuff that's all like terms. So I can see that I've got an x cubed here, x to the 3rd power, so I'm going to go ahead and start there. I always like to start with my biggest exponents. So if all right, here's an x to the 5th, or x to the 3rd. Here's an x to the 3rd. That looks like it. Maybe we do x squared. There's an x squared. Here's an x squared. Let's do triangles around our x's. And then, I don't know, we could just regular underline our constants. But now I'm just looking at all the different shapes to get stuff collected together. So for my x cubed terms, 5 minus 1 is 4x cubed. So that's those two. For my x squared terms, I've got 2 plus 3 is 5 plus 4 is 9. 9x squared. For my x terms, negative 1. Is that it? No, I'm missing one. Negative 1 and negative 4 is a negative 5x. And then for our constants, 7 plus 7 is 14, minus 8 is 6, positive 6. So 4x cubed plus 9x squared minus 5x plus 6 would be my sum of those 3 polynomials. The nice thing is, for subtraction problems, there's only just one extra step at the beginning. When we're subtracting 2 polynomials, we just know that when we're subtracting anything, whether it be a number, a polynomial, or anything, when we subtract, that's the same thing as adding the opposite. So what we're going to do here is I'm going to take this negative. So in this case, I'm doing negative 2x cubed plus 5x squared minus x plus 8. And I'm subtracting negative x cubed plus 3x minus 4 from that. So what I have to do here is I'm going to go ahead and distribute this negative, which is technically a negative 1, into those second 3 terms, those last 3. When I do that, my first terms don't change. Negative 2x cubed plus 5x squared minus x plus 8. And now this becomes a positive x cubed, a negative 3x, and a positive 4. And now that I have those parentheses gone, it's just collecting like terms. We're back to that same process we were just doing. So I got x cubed and x cubed. I've got x squared, and that's it. I've got x's and x's. I've got constants and constants. So for my final answer, x cubed, negative 2 plus 1. Right? Negative 2 plus 1 is negative 1. X cubed. I've only got that one x squared term, so positive 5x squared. For my x terms, negative 1 minus another 3 is a negative 4x. And then 8 and 4 makes 12. So there's our final solution. Last but not least, we've got x squared minus 8 minus 7x minus, or plus 4x squared. So once again, I'm going to start off by distributing my x squared, or my negative in there. So x squared minus 8 minus 7x minus 4x squared. And now x squared and x squared. And that's it. Those are the only 2 like terms. So 1 minus 4 is a negative 3x squared. Right, let's do this in a different color. X squared and negative 4x squared is negative 3x squared. My x terms, which would be that one, is just negative 7. And then my constant is just negative 8. So that would be my final solution. Only those first two collect together. Everything else is just their own separate terms. All right, that's all I got for you guys. Homework is up there on the screen from the bottom of your notes for those who have a hard copy of it, page 362, 6 through 38, just the evens. As always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you soon.